All right, this is our video for Monday, April 13th. Today we're going to focus our review on the relationship between the original, the first derivative, and the second derivative. Kind of got a plan for the week. Today, as I mentioned, the relationship between original, first, and second derivatives. Tomorrow, for Tuesday, I want to talk about reviewing particle motion. And then Wednesday, Thursday, Friday, I want us to do another practice test. I think these are really good ways to get our brain back into thinking, and they cover basically the entire year. And so I think it's a good thing for us to practice. And so we'll do the multiple choice on Wednesday, the open response on Thursday. You guys get those to me, and I'll get them graded. Multiple choice on Friday, and then we can talk about the results on Monday. Now, I wanted to talk a little bit about Aiden joined us for our Zoom on Friday and wanted to know how things had changed, or Thursday, Friday, sometime in there, since you guys are official graduates. You are still expected to complete your AP Cal class, so to speak, which means you're still expected to review and to take your test. But I'm not going to be taking any grades, but I am definitely going to be supporting and offering you every opportunity to review so that you can be successful on your test. So we're just going to keep working just like we always have. I just won't be giving you grades, but I will definitely be giving you feedback. Today, in your folder, you are going to find a packet. And this is just a resource. I found this a year or two ago, and it starts with beginning calculus, and it just goes through and it explains and reminds you of everything. So on continuity, to prove that it's continuous, you have to prove that f of a exists. You have to show that the limit exists, and you would have to show from the left and from the right, and then you have to show that the limit is equal to the value. And so this it walks through everything that we've talked about this year: average and instantaneous rate, Rayleigh's theorem, the extreme value theorem, inverse functions. And there I wrote that little formula down here that we're always forgetting, or that I'm always forgetting. And I'm sorry, this is kind of hard to read for me, and I hope that it scans well enough for you to look at it. It's just a really great resource: fundamental theorem of calculus, speed, velocity, acceleration. So this might be one of those things that you want to have handy on test day, along with your orange card. But again, it's not going to do you any good if you're flipping through here trying to find it. But if you have looked over it and really studied it, and you just want to double check real fast before you start that open response, this is going to be a great resource. So this is in your folder for today. It's just a resource. If you can print it out and have it on hand for test day, that would be really good. Now, what I want you to work on today is function analysis classwork. And this is kind of a weird document that I found, again, a couple of years ago. And it reviews you, and then at the same time, it's something that somebody obviously made for class notes for somebody to go through with them in class. And so, again, it starts out with review, and then it talks about how each one of these are increasing. It talks about if you draw tangent lines, and it's just kind of wanting you to make connections. I don't really want you to work anything on the first page. Again, that's just kind of information. I don't really want you to work anything on the second page. Again, it's just reviewing. Down at the bottom, it has this nice little chart about increasing concavity and the relationships. It's got some definitions over here. This one is really weird. It was example 1, and it says for each term determine if it is applicable. It's wanting you to look up here and then look at it and say, okay, well, A is a critical point. Yes. Is it a relative minimum? No, it's a relative maximum. And so they've answered the question is what I'm trying to say. These are the answers, so you could kind of look at it and see what it says. But here's where the work is. So we have the derivative, and they want you to graph the original. And so there's a couple of pages of that. And then here they're giving you information about the original, the second derivative, the first derivative, and they want you to kind of sketch a graph of it. And then when we get over to here, again, it's just reminding you of information, and then it wants you to practice finding max and mins and points of inflection, which is a good thing to do. So really, it's just a lot of information, another good reference. But then I want you to do these two inner pages where you have to practice drawing the original, and then see if you can draw a graph based on what you see here, and then practice. And again, there's 1, 2, 3, 4, 5, 6. Practice maybe one of the easier ones here, and then one with your trig, and then maybe one of these where you have to use the quotient rule. But just again, want you to think about that relationship between the original, the first derivative, and the second derivative. All right. Last thing, Cassidy mentioned that it's really hard working at home alone, and I know that we have always been good at working together in class and bouncing ideas, and sometimes we got off track, but most of the time we were working pretty good. So I need your help and wondering if we could figure out how to do an online study group. And we'd have to pick a time. I know there's not going to be a time when we could get everybody, but if we could, maybe in the evening, or I know Garrison's working a lot, maybe in the morning we could, and it doesn't have to be every day, but maybe we could try and get an online study group where we could go through some of these packets together, our open responses. I have, things that we could have done together in class, matching activities and things I'm trying to figure out how to do online. But they would all be a lot easier if we could figure out some kind of online study group time, maybe once a week, where we could get together and do some things kind of as a class. So think about that. Maybe you've got friends who are doing something like that. Maybe we could have a couple of them set up during the week, but just kind of think about that and let me know your ideas. Remember, Zoom is at 10:30 to 11 every day, and that's the closest thing we have to being in our classroom together. And so if you can join us, it is a good time. So I'll talk to you tomorrow.